Hello, Math 20-1 students. So today we're starting Chapter 7. We're looking at absolute values and reciprocal functions. So as usual, I kind of have your timeline laid out here so you can kind of plan your schedule for learning in this unit. So today we're going to start out by looking at absolute values. So just to get into that, we want to do a little bit of an investigation into some of the ideas that we'll be looking at. So using the following number line, we want to try and answer some questions. So the first one asks us to mark the values from mark the values +4 and -4 on the number line. What you guys might want to do here actually is pause the video and work through this on your own. It should be all material that you can do quite easily on your own, and then just come back and I'm just going to go through a quick explanation so you can always check your answers then. So mark +4 and -4 we have there, and describe their distances from 0. So we're kind of looking at if this is our midline here. So thinking about what's going on here, the distance from 4 to 0 is 1, 2, 3, 4 units. And the same thing is true for +4, 1, 2, 3, 4 units, right? So if we're describing just their distance from 0, we don't really talk too much about the positive and negative. We're just referring to the fact that each one is 4 units away from 0. Okay, this one is just to the left and that one's to the right, but we don't really describe that when we're doing math like this. Okay, then the next thing is plot 2 points to the right of 0. How many units are between the 2 points? So, I don't know, we can do one maybe at 2 and maybe one at 5. How many units are between the 2 units? So between 2 and 5 we have, you can just kind of go 1, 2, 3. So there's 3 units between the 2 points. And you could have chosen a different one. So you would just count the units, repeat the previous step using 2 points to the left of 0. So I don't know, let's do maybe 7 and 4. And then we want to figure out how many units are in between there. So we have 1, 2, 3 units, actually again between these two. I didn't plan it that way, but that's the way it turned out. So what do we notice about the numerical values of your calculations and the number of units between the points in the previous two bullets? So basically, if we would have determined the number of units mathematically, what would we have done here and what would we have done here? For me personally, I would have done 5 minus 2 for this one. So 5 minus 2 would give me 3 units. And for this one, I would do -7 minus -4. -7 minus -4. Although that would have given me -3. Sorry, I'm running out of room there. And so, okay. That's going to bother me, so I'm just going to have to move that over. Okay, so 3 units. Okay, so we end up with -3 here in our calculation, but still if we describe how many points are between them, we just say 3 units. We don't say -3 units. And so if you think about what's the association between these two, it's that regardless of how we would calculate them mathematically. So with this one, we actually end up with +3. With this one, we end up with -3. But regardless of how we calculated them mathematically, when we describe them, we still always say that they're 3 units apart. And so it asks us what we notice about the signs. And so, of course, this one would be -3 and this one would be +3 if we were just doing the math. So they have opposite signs even though the numerical value is the same. So basically one is positive and one is negative. And then the last question is explain why the distance from 0 to +3 is the same as the distance from 0 to -3. Okay, so if we were to go from 0 to 3 on either side of the number line, like we just saw in these previous ones, we would say that the distance between them is 3 units. And so that's the same value, right? So with math, basically, if we're describing the distance from something, distance is kind of considered to be an absolute value, which basically means that regardless of whether mathematically we would calculate it as positive or negative, we always list it as a positive number. Okay, and so even if you think about, like, if you say how far are you from someone, you never say I'm like -3 feet away. You would always say I'm 3 feet away. If you've taken any physics, you might kind of know that distance is the absolute value version of displacement. So when we're using distance, we only refer to positive values. So if you start at like 0, let's say here, and you walk 3 meters to the right, and then you walk 5 meters to the left, if we ask how much distance did you travel, you would say, well, you went 3 meters and then 5 meters, so you would say you did a total of 8 meters. Now with physics, sometimes you can do displacement, which is basically how far are you from where you started. And so in that case, you would only be 2 meters to the left of where you started. So that would be your displacement would be -2 meters. So that's a little bit of like relationship with physics here, is thinking about the different terms. So if you have experience with that, that's kind of good, because it'll help you to understand this a little bit better and know that distance, and what we'll be talking about for the remainder of the chapter in this course, is always going to be the absolute value, the positive value. So even if you're going to the left on a number line, we kind of refer to it in as a positive value. So some key ideas that we want to know for this unit are that if you want to have something represented as an absolute expression, or absolute value, sorry, you always place two vertical bars around it. So like here we have A with these two lines on either side, and that means that even if you had like -5 in here, the absolute value of it would be 5. So basically what it is the absolute value of a negative number is the negative of that number. So when you see like a negative value inside of these absolute value bars, it's kind of like saying that you're taking the negative of that value inside of the bars. And so negative times by -5 gives you +5. Now, if you have a positive value inside of those bars, the value remains positive. Okay, so basically, regardless of what's going on inside the bars, the absolute value of it is always the positive version of that. If you have 0, then the absolute value is still just 0. And so yeah, it mentions that here. The absolute value is always positive. Okay. So absolute value can be used to represent the distance of a number from 0 on a number line, just like we saw on the previous page, right? So if we had -3 was kind of like our units in the second bullet there, I think, we would write it like this, -3, but the distance, like we said, was 3 units. So even though we have -3 in here, the absolute value is +3. Okay, so if we wanted to evaluate the following absolute values here, we have the absolute value of +9 is just going to be 9. The absolute value of -12 is like negative of -12, which is just 12. Okay, so pretty straightforward. Basically, just anything is always going to be positive. The next thing we should be able to do is write the real numbers in order from least to greatest. So if we look at our values here, the only ones that are going to change are the ones that are in absolute value bars. So this first one is in absolute value bars. That's going to be 3.5. Okay, this one stays as -2. This one is -5.75, but it's in absolute value bars, so it's actually going to be +5.75. 1.05 stays the same, but -13/4 becomes +13/4. And in order to compare it to these other values, we also want to take it out of a fraction. So 4 times by 3 would give us 12. So we have 3 whole values in there, and then we have 1 remaining, right? Because 4 times 3 would be 12, and we have 13. So then we have 1 more out of 4. So our total value here is 3 1/4. For negative 0.5, we have 0.5 would be our value. Negative 1.25 stays the same, and for this one we would have positive 3 1/3. So if we want to arrange them from least to greatest, our lowest number value here is the negative 2, so let's start with that one. Then we have negative 1.25. Let's see, then we have, I think it's going to be 0.5 will be our next one. Then the next highest will be 1.05. And then what else do we have? 3. So it looks like it's going to be the 3. So 3 1/3. No, sorry, 3 1/4 is the lowest. And then 3 1/3. And then, let's see, we've done those. So 3.5 or 3 1/2, we could always write it like that. And then last of all would be the 5.75. Okay, so there's our values arranged from least to greatest. Let's see, so just a little reminder, absolute value symbols should be treated in the same manner as brackets in terms of like when you're thinking about your order of operations. Okay, so always doing everything inside of them before you start to do other operations. So yeah, solve the inside value first, and then you can move on to the following. All right, so we want to be able to evaluate some equations with absolute values. So in the first one, we have negative 4 minus negative 3. So like we said, first, make sure that you've evaluated what's inside the bracket. So negative 4 as an absolute value is just 4, and negative 3 as an absolute value is 3. So we keep our mathematical sign, 4 minus 3, and so the answer to that one is positive 1. For this one, we have negative 12 plus 8. So negative 12 plus 8 gives us negative 4. So again, do what's in the brackets first. Now that we have our value, we can evaluate it without the brackets. So negative 4, and if you apply the absolute value to that, we mean positive 4 there. And then in this one, we have 12 times negative 3 is negative 36. Plus 5 squared is 25. Negative 36 plus 25 gives us negative 11. And now we can evaluate this as an absolute value. Negative 11 as an absolute value is just positive 11. So there's our answer for that one. Okay, so you guys have some ones that you can try on your own. If you want, you can pause the video here and give those ones a try. Remember that you can check the filled in notes for the full worked solution for those. So if you aren't sure how to get the answer on one of those, you can just check it out on there. And then lastly, let's try an example here where we're working with a word problem. So Wesley volunteers at a local hospital because he's interested in a career in healthcare. One day he takes the elevator from the 1st floor to the 6th floor to see his supervising nurse. His list of tasks for that day sends him to the 2nd floor to work in the gift shop, then to the 4th floor to visit patients, and then to the 1st floor to greet visitors and patients. What is the total change in floors for Wesley that day? Now, if you like the worked example in the book of this covers it kind of in this way where you're setting up an equation in terms of absolute values, which, I mean, that's obviously like what they're trying to encourage. But personally for me, I just looked at the values and I didn't want to make it. I found that this was kind of complicated. So all I did was say, okay, so he takes the elevator from the 1st floor to the 6th floor. How many floors of a change is that? It's going to be the 6th floor minus the 1st floor, which is 5 floors. Okay. And then, yeah, we can put absolute values around it because we want to know his total change. So if he ever goes negative, we don't want that to affect it. His list of tasks, so he goes to the 6th floor to see his supervising nurse, and then from there, she sends him to the 2nd floor. Okay, so now he goes from 6th floor to the 2nd floor. So 6 minus 2 gives us 4. Work in the gift shop, and then to the 4th floor. So he goes 4th floor minus 2. So basically, I guess I'm kind of eliminating the need for the absolute by just choosing the higher one and subtracting. 4 minus 2 is 2. Then to the 4th floor to visit with patients, and then to the 1st floor to greet visitors. So he's in the 4th floor, and then he goes down to the 1st floor. So 4 minus 1 gives us 3. And so his total number of floor, or total like change in floors, would be the sum of these together. So that's kind of like what this was illustrating here. So 5 plus 4 is 9, plus 2 is 11, plus 3 is 14 floors is the total change. Okay. So with these types of problems, like even if you were on a test, total change in floors, even if you were on a test, like do what makes sense to you mathematically, okay? Unless you're specifically asked to use absolute values or represent absolute values in your solution, I would say do what makes sense to you. Like that's always what we want to do with math, right? Not be forced to use something that doesn't make sense to us. So as long as you get mathematically the right answer, as you work through these practice problems here that I've assigned for you out of the textbook, make sure that you are like figuring out how you're comfortable with working with these types of problems and be able to use that consistently for solving your problems, because that way, you know, like even on a test, if you had a written question and you were asked to represent the absolute values and you weren't totally sure of it, like how to represent it, at least if you knew how to solve it, you would still get part marks for working a proper solution and getting the correct answer, right? So just remember that with written questions, you'll always get part marks for being able to do the work correctly, even if you miss out on a little bit of some of the components of it. Okay, so that's everything for today, really quick and easy, but do make sure that you try those practice problems, especially the word problems tend to be the trickiest ones. And next time I'll see you in lesson 7.2, where we look at absolute value functions.